Some of the best information about the atom has come from looking at their atomic emission spectrum. It's not as complicated as it sounds. You simply take an ionized form of that atom, for example, hydrogen gas, run a current through it, and then take a look at the light that is emitted through a prism, and you will see lots of sharp lines. Or perhaps they'll call them principal lines, these thicker ones. Perhaps they're diffuse, perhaps they're fundamental. Those were the beginnings of what became known as S, P, D, and F orbitals. And the entire periodic table has to have been divided up into those groups. And if we can discover just a few more elements, we're going to find the G group as well. This is known as the Aufbau order, and let's have a look. Bohr supposed that atoms consists of a nucleus with some electrons, and they reside in shells, the first shell, the second shell, the third shell, the fourth shell, etc. A closer look at this emission spectrum and some other fancy math led to the observation that there's not only shells, but there's also subshells. So this is what the detailed look at it revealed. Sure, you have electrons in that first shell, you have some electrons in the second shell, but also within the second shell they can be divided into these principal bands, or what's known as the P subgroup, and they look like regions like that. You can go up into the third shell, and you'll have a couple electrons residing in that area, but also you'll have some in the P subgroups as well. So this is just a closer look at the Bohr model, if you will, and it's closer to our current understanding. I think it's helpful to think of them as simply shells that have subshells within them. We have some notation for that. We call it electron configuration. For a given shell, first, second, third, it can hold a certain number of electrons. These are divided up into atomic orbitals, which are simply pairs of electrons. And then we can put it all together to come up with a notation that tells you what's going on. You have the level, first, second, third, that's your shell. You have the orbital type, it can be S, P, D, or F, and it can hold up to a certain number of electrons. Let's have a look. In the first shell, we can hold up to 2 electrons, and that'll define the electron configuration of hydrogen and helium, right? 1 electron and 2 electron systems. And it's a sharp band was observed, so we call that an S subshell, and it can hold up to 2 electrons. So the first shell is an S orbital, and it can hold 2 electrons. The second shell can hold up to 8 electrons, but there's some subshell nature to it. The first 2 electrons go into another S subshell with a larger diameter. That's called the 2s orbital. It's a pair of electrons. So we would say the electron configuration of atomic number 4, atom number 4, element number 4 would be 1s2, 2s2. Moving out to more detail in the second shell, there are 3 P subgroups, the P sub x, the P sub y, and the P sub z. All 3 of these can hold 2 electrons each. So we have now 6 more electrons. We call that 2p6, consisting of these 3 orbitals here. The electron configuration of neon is 1s2, 2s2, 2p6. Let's go all the way out to argon. We need to go now out to the third shell, which begins with the 3s orbital, so that will be 3s2, and I believe we're now at magnesium. We go out 6 more, and just like for the second shell, there are 3 P subgroups. 3P sub x, y, and z. The electron configuration of argon is 1s2, 2s2, 2p6, 3s2, 3p6. This is the Aufbau order.